Hi there, good evening everybody, and thank you for taking time out to be with us this evening. I'm Heather Barrett, Head of Marketing at ProCam, and I'm your host tonight. Tonight is all about practical decision making, using the right information to improve crop performance, input efficiency, and ultimately farm profitability. So over the next 45 minutes or so, we'll show you how FieldSense helps turn soil and crop variability into clear, actionable plans backed by agronomy, not just data. And that really is a key to our FieldSense platform. We'll also share some real world examples of how growers are using it on farm. Then it's not just all our words, making it up as we go along. If you have any questions as we go along, please use the QR code on the screen. This will allow you to submit questions directly to the panel, and we'll pick up as many of these as we can during the Q&A at the end. The QR code will be on screen at all times, so please, simple, scan it with your phone, pop your question in, and we'll capture those at the end. So FieldSense and its story. ProCam's FieldSense wasn't created to follow a precision farming trend. It was delivered to solve a real issue that we see every single season, and that is variability. No two fields are the same, and often no two areas within that field are the same. Soil type, nutrient status, drainage, organic matter, all of those might vary, yet traditionally we've managed fields as if they've all been uniform. FieldSense bridges that gap. It brings together soil data, satellite imagery, and practical agronomy to support better fertiliser decisions, smarter nutrient planning, and therefore more consistent crop performance. But it's not technology for technology's sake. It's about giving growers clarity and control in a margin-sensitive and environmentally focused world. And importantly, it's not a platform that we hand over and expect you to figure out alone. You won't be drowning in data or learning new software. FieldSense is a decision support tool used by your agronomist with you. The data informs the conversation, but the value that comes from interpretation, experience, and practical recommendations. Ultimately, it's not about the data. It's about making better decisions together. But rather than just hearing it from me, I'd like to bring in two people who've been involved from the very start, both in developing FieldSense and using it day to day with growers. I'll hand over to James and Nigel Scott to introduce themselves and share where FieldSense began and why it matters. So Harry.
Thanks, Heather. Yeah, so I'm Harry James. I'm an agronomist over in kind of west of England, Welsh border area. I kind of got involved with Nigel in creating this project about 3 or 4 years ago when we realised that what we were doing on farm could improve, really. I think we all know the phrase devil's in the detail, and that's why hedges are where they are. And we wanted to kind of improve that level of detail, ultimately to improve output on farm. At the time, we kind of looked what else was out there in the market, and nothing really fitted what we wanted. We kind of had that very kind of practical angle, and we knew what problems we needed to solve. And really, for that to happen, we had to go and do this ourselves and build it ourselves. So we think we've come at this from the kind of right practical way, that balance really between, I guess, tech and being on farm every day. So yeah, you'll see shortly, but that's kind of where we're from and what we're about, really.
Perfect. Thanks, Harry. Nigel.
Thanks, Harry. Thanks, Heather. My name is Nigel Scott. I'm an agronomist working up in the northeast of England, up in Durham. I've worked for ProCam for actually over 30 years now. And I think really, ProCam is built around strong agronomic solutions. Agronomy is the sort of key driver to our business, and a good agronomy is key to providing the best practice to our growers, helping them to maximise overall farm profitability. Now, FieldSense was developed, as Harry mentioned there, starting about 2-3 years ago, and was developed to enhance ProCam's offer into the marketplace. Now, one of our key values in our business is solutions, not inputs. It's important that we use these values in any product we bring to the market, and FieldSense is no different. We started to develop the platform to offer class-leading service, working in close partnership, as Harry's mentioned, Heather mentioned there before, both with the grower and the agronomist. We feel when you work together, you get the best solutions, and I think that's really quite key. It's vital, especially when margins are tightening as well. And our approach is clear, that you need boots on the ground when it comes to ensure to maximising the potential of any data you're using. FieldSense was developed and has been developing over the last few years alongside our key values around agronomy and partnership.
Fantastic, thank you both. Now there's no better way to explain what a platform is all about than to demo it. So that's what we're going to attempt to do now. So fingers crossed, the technology is playing ball. Let's give it a whirl, guys.
Good evening. I'm going to start this evening's demonstration with a quick overview of the platform and also working towards making a nitrogen application map. The platform is an online platform where you can see I can now sign in. It's got a range of capabilities that are both precision and broadacre. Tonight, we'll be focusing on variable nitrogen applications. And once you've got a field boundary uploaded to the platform, the first step in making those applications is creating a field grid. For that, I will click on the field grid tool. This has loaded up a list of our farms that we have on there this evening. I'm going to select from the list Greystones Farm. And the field I'm going to select for the example is trackside. I now have the ability to click the plus button here, which creates a new grid. I can name this grid, and I'll now move on to the next step. We can use a range of imagery and data in the background to create this grid. For example, a high resolution drone image or other. But for this example, we're just going to use the image we have here from Bing Maps. We have a range of profile types. This can either be manual, machine, or analysis profile. And these are some pre-populated designs that are appropriate to a range of generic bits of application equipment. You can see here in the list, I've got some different sprayer sizes, some different drill sizes, and some spreaders. You can save your own custom machinery within here, so it's quickly selectable when you make a new grid. We can change the grid boundary, but for this we'll use the full field boundary. You will notice as I have selected machine profile and 20 meter sprayer, which I'll just change to spreader, it has added a boundary, a headland boundary into this field with an offset of 24 meters. So if we look a little bit further down, we can see that this is the design of the cell that we're now creating, width and length. Width is determined by the width of the application equipment. So if we're looking at a spreader or a sprayer, then we are obviously the width of the tram lines. If we're looking at something like a drill, then we are most likely narrower than the tram lines. So here we have a 24 meter spreader. So I've got that set to 24. And the length of the cell effectively determines the level of detail we're going to go to. If this becomes too small, then the spreader is constantly changing its application rate, which you'll never achieve consistency then. So having a cell of 10 meters in length is a good balance. We do have the ability here to add a buffer width if we want to put a buffer around the whole outside perimeter of the field. And we've got the headland cell function, which we have got turned up on at the moment, which you can see has put this headland black line in around the field boundary. If I untoggle that, you'll see that disappears. Select Selecting that again, I've now got the same width, 24 meters, length 10 meters, and I can put multiple headland boundaries in. As you can see, I've now upped that to 2. In most applications with sprayers or spreaders, we'll be using 1 headland. Maybe some applications where we may have a trailed sprayer that's quite long, that you may drive through the headland tramline onto the second one. And certainly when you're drilling, where you'll be going around possibly 4, 5 or 6 times, you will have multiple headlands. Below this, we can see we have the grid orientation line. Once we're happy with our size of our grids by design, we can now orientate the grid to the fieldwork. This is important because it means that you have a very stable application rate. We don't have the tractor or applicator driving close to a boundary of a grid along the length of the field. So when it is in a zone, it is in the middle of that zone, and it is not jumping between a couple of zones if we have a change in satellite accuracy. This is particularly difficult when we're talking about liquid applications with sprayers, whether that be fertiliser or ag chem, because the Ramsey valve struggles to change rates rapidly. So if you are rapidly changing rates, then you're inherently going to be under or overdosing as the machinery cannot keep up. So just going back to our grid orientation here, what we're looking to do is create the grid in line with these tram lines and with the tram line in the middle of the grid. If I click on this pencil, my cursor will turn to a circle. And I can see in this field particularly that the field's been drilled with this straight boundary here. So if I click twice, I put the grid orientation line along that boundary. And then if I hit generate, you'll see it creates a grid to match those tram lines. If I just turn down the grid, you can see that our grid is indeed exactly either side of that tram line, which means as that spreader or sprayer comes up that tram line, it's not going to be anywhere near this boundary, so the rate will be consistent. We can save this line if we like for future operations. Should we wish to use that again. Now if you hit generate, we can move on to the next step. Here we have the merging tool. This enables us to alter the auto merging function of some of these cells. As you can see in the corner, that these grids coming on here have merged into a larger block to save there being lots of tiny cells with different rates in the corner. We can alter these rules, but generally leaving things at 50% works about right. There is a manual merge function if we do wish to create any larger cells manually. This is particularly useful if making a trial, but for this example, we'll leave it on auto. Going to the final step locks that grid to prevent any unintentional modifications. And now we have created the grid for that application on that field. This is best done together with agronomist and grower. I find sitting in the farm office, looking at tram lines and discussing planting orientation is very useful and creates the best outcomes for the applications. You obviously can use the Google Earth or Bing Map images, and you obviously can ground truth things yourself in the field. But like I say, working together on this seems to get the best outcome.
So you've now seen how practical FieldSense can be, tailoring different grid sizes to match in-field operations. This produces more accurate applications in the field. We are now going to move on to how we can produce variable rate nitrogen plans to increase nutrient use efficiency and overall gross margins. Nitrogen plans are produced using NDVI images taken from satellites. There are two types of satellite that we use. The first is Sentinel-2 that produces a resolution of 10 by 10 meters with a frequency of imagery of around 5 to 7 days. The other satellite used is PlanetScope with a higher resolution of 3 by 3 meters and a frequency of images of around 3 to 5 days. Both are widely used and offer good reliable sources of NDVI images. We can now see how the two different images look on the same field this spring. Sentinel-2 on the left and PlanetScope on the right. They both pick out the higher and lower biomass areas of the crop. Both image types can be used to produce accurate variable rate nitrogen plans. On the screen now, you can see the grower dashboard, which every FieldSense customer can access. This dashboard allows the customer to access reports, spreading files, soil sample results, and any other product that has been purchased. This also sits alongside accurate field-by-field weather forecasting. Our focus this evening is around variable rate nitrogen, so we're going to use the results viewer to view the latest satellite imagery that has been taken on one of our demonstration farms. You can access these images by simply clicking on the results viewer, picking the product we're going to use. In this case, it's going to be satellite imagery. Picking the type of satellite we're going to use, which is PlanetScope, and then we can home into the fields. If we click onto the farm and the icon, we can zoom into the farm itself. Now we can see the images on the three fields in the image here. You can now see the variation in this crop of oilseed rape from the image taken a few days ago. Individual fields can be selected, field blocks or whole farms, allowing you to view the fields in more detail. From these images, we can now look to produce tailored variable rate nitrogen plans. Ground truthing and working in partnership with the grower is crucial to provide accurate plans. FieldSense can use all fertiliser types, including liquid and solid products. The picture on the screen is a field of oilseed rape taken in North Yorkshire. Using NDVI imagery, we can pinpoint differences in biomass within this crop. Looking at the image, you can clearly see the differences. Ground truthing is key to get the most out of a variable rate application. The biomass, or GAI, varies across the field. The two pictures show a GAI of 2.02 and 1.38 from different areas in the field. The biomass of oilseed rape is directly linked to how much nitrogen the crop has taken up. This allows for accurate VRA maps to be made to maximise the crop's potential, increase nutrient use efficiency, and overall profitability. VRA nitrogen can also be used in cereal crops to again maximise NUE, reduce lodging risk, and crop quality. Using the ground truthed image, variable nitrogen plans can now be made. Combining the bespoke grids with the in-field knowledge gained, we can now produce the best quality nitrogen plan and provide a class-leading solution. To view this plan that's been made, we'll go to Application Map. Up here, we'll pick the product that we're trying to vary. In this case, obviously, it's nitrogen. Then we're going to pick the plan. The plan that was made here was a variable rate application of nitrogen to some oilseed rape, and it was its first application, so we pick the application. You can now see the image that we've used. Now we can see the bespoke grids that were made to match the machinery, and these can be used to overlay across the NDVI image. Here we can see the product type has been picked. In this case, the fertiliser to be used is Nitram. Rates have been determined in conjunction with the grower using the images in ground truthing. We can see a range of from 55 kilograms here up to 105 kilograms of nitrogen per hectare. Here we have the totals for the farm job and each field. These can be tailored to fit the amount of fertiliser you have, or rounded up or down to fit bags, etc. The map now is merged, similar cells together, to a more homogenised view. From here you can download shapefiles or ISO files by clicking on the download button. The download will pop in the right hand side of the screen and we simply open it up. So within here we can see the different types of shapefile that are used, or inside here is the ISO files. Also here we have a report. The report generated showing the spreading maps and the total needle needed for each job. This is only one element of FieldSense that we've demonstrated this evening. The platform provides more features to allow the grower to maximise output when utilising precision farming. Key to this is partnership. Working together provides better outcomes and stronger solutions.
Wow, excellent demo there, guys. Thank you very much. Before we move on, I just want to remind everybody, please, if you do have any questions to put to the panel this evening, scan that QR code in the top corner and it will take you straight to our question form. So great demo there. Clearly there's a huge amount of bespoke functionality within the platform, but what happens next? How do we put this data into practice?
Thanks, Heather. Yeah, no, again, we've put together another quick video to show easy you can put vari files, whether it's seed or fertiliser from FieldSense onto your machinery.
Fantastic. I'll just run that and then we'll come back with more questions.
So taking the USB stick from the laptop there with the RX files and those shape files saved within them, and I put it into the USB and I placed it into the back of here. Now the ports for the USB in this particular John Deere is in the back of it. This is an older screen here, the new screen on the side of the tractor here, as to the side here. Placed in the back of here, this is for the guidance. So I've pushed it into the back of the actual screen itself. Now I was waiting to pick this up. Actually, USB is a little bit temperamental on the on this one I've placed onto it, but it should take a couple of seconds. Now we can see here, it's picked that USB up. The first thing we want to do here is import data. So now it's going to read the files actually on the USB stick itself. Again, just take a couple of minutes to whirl around at the moment. You can see now asking us if we want to import from the USB drive and say next, yes. Now we can see it's into this is the Gen 4 data. Pick it up onto that, so we want to load it onto this screen. There are the RX files. We can see the 3 prescriptions for 3 fields we've just done. Click onto that and import. Now it's going to import, so now we can see the import was successful and we can take the USB out. We've seen in the first part of the video that you can upload the shape files for a job you're trying to do directly to the tractor using a USB stick. More common now is using platforms such as John Deere Operations Center. Within Operations Center you can download files and assign them directly to the tractor. So we'll show you how to do it here. So first we're going to go to more files and we're going to upload and assign and send files to machines. This can take some time. Upload some files, descriptions I've actually made. Choose the files we're going to import into it. These are some nitrogen files I've just done. Now we're going to upload them to Operations Center. These have been uploaded. Now into prescriptions. Again, this can take a couple of seconds to come through. Now all those 5 fields have been uploaded. If you select them, we can now transfer to equipment and transfer it directly to a tractor. On this page here, we can pick the tractor we need to do. So for instance, pick this tractor top here, and we can transfer it straight to the tractor. So all the data in terms of the VRA files, nitrogen files in this situation, have all been transferred to the tractor. Simple way of doing it.
Great stuff. Nigel, is it really as easy as it seems?
Yeah, it's a very simple process. You can see hopefully from we adding files directly to tractor into tractor box, or using a USB stick, or using platforms such as Operations Center from John Deere. It's a simple process to add your VRA files from FieldSense. Now, ProCam agronomists, I like to add now, we're not all IT specialists, but we do have a strong background in knowledge and the practicality of inputting data into machinery. We also have strong relationships with machinery manufacturers to help where needed. An example of how easy it is to use FieldSense. Yesterday I was walking some crops in County Durham. I checked on the overall growth stage and overall crop health. We made some VRA plans using FieldSense, and I was having my lunch. By the afternoon, the growers applying nitrogen to the crop. As I've said, it's about partnership between the grower and the agronomist is key. But it's a simple process and can be done very, very quickly, whether it's at night time and you finished your crop walking and you do it using an operations center or other platforms as well, or whether you've got the ability to walk in the fields in the morning, write your recommendations and apply them straight into the machine. It can be done either way, but it's a very, very simple, easy process.
Fantastic. So clearly the agronomist's role in the successful use of FieldSense is absolutely paramount. Harry, have you got an example you can tell us about where the importance of the agronomist's real in-field knowledge has come to the fore?
Yeah, I think that bit where we're in the field and we're ground truthing, I think Nigel obviously showed a nice, beautiful photo of some rape there. But it's really important actually, and literally a phone call I took late last week where an agronomist had a variable rate plan he'd made. He went to go and walk the field of oilseed rape, this was in Cambridgeshire, to kind of verify what he saw was correct and kind of look at those GAIs. And he was pretty chuffed because it picked up the bit of rape that they actually re-drilled about 4 days later after the first drilling. So that was good. But in the top corner of this particular field, the image, the NDVI image, showed a poor crop and a high nitrogen application rate. And when he got there, he thought this isn't right because there's a lovely crop of oilseed rape here. What's happened? Basically, he had a look at the RGB, the red, green, blue image of the satellite image, and it actually had a bit of a wispy cloud. Now, obviously, we need line of sight for photos, and clouds get in the way. But most of these satellite services, what they all do, they have this kind of cloud screen, it's called, which kind of cleans up images and gets rid of clouds. But occasionally sneak through. Now, if he hadn't really have looked in the field, he probably would have assumed, yes, that bit isn't very good. But because he got out there and had a look, verified that wasn't the case, worked out why with kind of like detecting that cloud. He then went on to, well, initially his plan was I'll just kind of do a manual rate. So those individual cells we can kind of pick and select our own rate, so do a rate that you would base your own kind of visual inspection on. What happened actually was he got a new image yesterday. So he's kind of used that new image from that satellite service, sent the plan out actually last night to grow, and I think they hope to be on today. So I think it's just really nice to hear, he thought it was broken. Actually, I think it's a perfect example of how it isn't broken, of kind of linking his observations with data, and it's not just creating data, it's about kind of, genuinely building yield, better crops.
Perfect. Nigel, we've heard about FieldSense from the agronomist point of view. How efficient is the platform for a grower to use, and what can they expect to best get from it?
It's very intuitive. As I say, all FieldSense recommendations are made using the agronomist platform, and this is to ensure that applications are correct. It's important, and they're made by a fact qualified advisor. But as I shown from the first part of the video, and I showed there the grower's side of it, there's a grower version which allows the farmer to view all recommendations made. view all the results they have. Download reports is important, within view the results as well. This is increasingly important with, looking for reports, for instance, for crop assurance or for EA visits, and obviously you can also download any VRA files as well. The Grow version is simple to use, and it can be accessed by a computer tablet as well. But it's a very simple operation. Again, it's a situation where if you're interested and you want to use it, it's certainly a case of emailing your local agronomist, and then again we can upload you to a grower user. But it's simple, and I say it's important, it's intuitive as well.
Excellent, thank you. Just to say at this point, thank you very much to those people who've already submitted questions. If you do have a question, please use the QR code, that way, and it will come through to us to answer at the end. So moving on, Harry, can you share a real good grower example of FieldSense in action? So where did they start? What changes have they made since signing on to the platform? And most importantly, what measurable impact have they seen on farm?
Yeah, okay. I think, well, a bit, we all know that SFI has had quite a big impact upon precision agriculture. And we've seen a lot of people kind of sign up for what is PRF1, so variable nitrogen or variable nutrient application, should I say. And what I have in mind is someone that signed up for that service, kind of, I think, obviously driven on by effectively that kind of grant funding, but I don't think they've regretted it. So this is actually slightly going left a little bit off nitrogen onto kind of soil sampling and P's and K's, but it's still about that detail really. And a colleague of Nigel and I's was down in kind of Bucks, I think he is. He had quite a large field, and he'd done a standard W, which we all do as we have to for a tractor on that field, and he'd been doing a very good job managing the pH on that field, keeping it just about spot on. Anyway, he came along to precision agriculture, and they always had this patch of the field which the oilseed rape never grew in, and they always wondered why. So they thought, well, this is a good place to start with this SFI kind of driven PRF1. So anyway, they went on to 1 hectare grid sample this field, and turns out his W wasn't doing the best job of representing that field. Funny enough, we probably already know this ourselves really deep down, but about 25% of this field roughly was about below a pH of 6. I think his average was 6.5, but it went from about 5.9 to something like 7.4. Obviously not all crops like growing in that big range of pHs, and funny enough, exactly where that oilseed rape wasn't growing, that top 25% of that field, or northern 25%, was exactly where the pH changed. So he was kind of assured, but also alarmed that this had gone amiss really for so long. So I guess the outcome was obviously then he variably applied some lime, which is quite instant, and now he can grow oilseed rape on 25% of his field, which I guess is a win, isn't it, really? So no, and they've gone on to do a lot more of the farm subsequently and found similar variation. So I think and that's kept building there really. So a really nice story. That's about 2 years ago that was.
Wow, excellent. Nigel, you must have plenty of similar occasions. Can you tell us about one?
No, there's a couple really, but one today actually, and the one from last year, and I think it sort of echoes sort of the sentiments that Harry's been putting through there. Scenario where one of my growers was looking to do some variable nitrogen, use another provider. From the imagery, you could see that was sent through from the satellite. There were some areas where there was quite large areas and the biomass was very, very low. Again, that was similar sort of scenario what Harry was saying. That was down at 1 thing pH. The recommendation for nitrogen was made by somebody remotely in an office, probably about 200 miles away. Looking at the biomass maps there, you could see the situation where that area, using the imagery and the person 200 miles away in an office, ended up with a situation where that was applying over 100 kilograms of nitrogen. As the farmer got the VRA file up and he's putting 100 kilograms of nitrogen when there's no crop, it's not exactly very practical. And I think that actually goes back to, our strap line of precision and partnership, which is crucial, because if you're ground truthing this stuff and walking it yourself, you can actually understand why there's a problem, why there's low biomass. And again, with Harry's situation there with these bespoke gridding and merging cells and blocking stuff off, you you can quite easily take that practically, and we've taken that in consideration on the farm now, and taken areas out where we know there's no crop or there's little crop there, and any amount of nitrogen making a difference. So again, it's more efficient for the grower, whether it be nutrition efficiency, and more efficient financially as well. But again, today I've got an example using FieldSense where it's benefited the grower. Looking at some satellite imagery last night and viewed the wheat as a block rather than individual fields, and this allowed me to capture the clear differences in crop development. From that, I tailored some nitrogen plans to maximise nutrient efficiency, and without this, he would applied a blanket rate of nitrogen across the block, leading to suboptimal nutrient efficiency there. And on this particular farm, we've adopted spatial cell sampling as well for the last few years, which has made a big benefit to himself. More even crops, again, saving some money as well. And again, this has led to better use of P and K applications, including more efficient use of organic manures. But as I said before, it's this partnership that's key in working together, and the ground truthing element.
For sure, but it really is making a difference on farm, and you're seeing it regularly, clearly.
It is. It's going back to that. It's better crop growth, better use of the nutrients he's got. But we're all here as a business as well, and it's about profitability as well, and that's key, especially when inputs, the margins are tighter as well.
Indeed. And speaking of kind of the various range of inputs, Harry, so this evening we've talked with intent a lot about variable rate nitrogen and applications thereof, but what about variable rate seeding? What can you tell us about that?
Well, it's the best bit. It's my favourite bit.
Okay, why is that?
No. Well, I think it's about setting that crop up, isn't it? Will it be, half sown or whatever, well sown, half grown, isn't it really? Which I think we probably all feel how the fields look out there at the moment. And I think if you do get things set up correctly, and by that, obviously, I mean an even plant population. It's not just about that. Obviously, we're talking about structure in the soil and everything like that, isn't it really? And planting the seed right way up. But no, it is about getting that set up, and then it takes away that variability later on. And if we're going to get maximum yields, then we need consistent ears, tillers, and grains per square meter. And if we can get that all done in September, October, then I think it sets us up for a win, really. So I think, and also you just see like so much variability in so many fields. Okay, there are some consistent soils out there, but so many of them, I go around and do tiller counts and stuff, and I'll go from 2,000 to 700 in the same field kind of thing. It's massive, the difference, that we don't appreciate how wide ranging it is out there.
Gosh, Nigel, any comment from you on seeding before we move on to the Q&A?
Yeah, I think I sort of echo what the sentiments that Harry's been saying. If you're going to vary anything from the start, certainly seed's the biggest influence. And again, we've done quite a lot of work between the two of us in terms of ground truthing this, and understanding where we were and where we are now in terms of before and after, sort of with VRA seed. And again, you have to be quite brave as well with seed. The variations, as Harry said before, can be vast. So it's been brave in understanding the soil type, and then and varying your seed accordingly. But we've had differences with over 100 kilograms a hectare in terms of seed rates from the sort of top to the bottom, and achieving the same result with the same tiller number when it comes to the spring. So it works very, very well.
Fantastic. Thank you both. That's been really, really insightful. We'll now move on to the Q&A session, because we've had some great questions through. So thank you so much to everybody who submitted. We've got about 5 or 6 minutes left of the session. So let's see how many we can rattle through, and try and address as many as we can. So kicking off, here's a good one. Harry, I'll come to you about this. So all about the finances. What's the financial benefit of using variable rate NPK? i.e., says our audience member, how much money will I make?
So I'll start with N, and I might finish P and K there. Well, it all depends about your land, really, I guess. If you do have a beautiful even field of even crop that isn't very variable, then obviously there's no point in varying on nitrogen. Not many people have that. Most fields are inconsistent. So pretty much your range you're looking at is probably 3 to 10%, depending on that variability of benefit. So 3% more output, probably today 40 quid maybe a hectare, up to maybe 160 for that 10%. So that's kind of what you're looking at as extra output really from a nitrogen perspective. But it does depend about, you knowing your field. Obviously in conjunction with the agronomist, but there's no point throwing variable rate something at a very consistent crop. P's and K's, I take P's and K's a little bit of a different way really. I think P's and K's are about kind of probably saving rather than pushing crops really. I think like I just said with that lime example really, we've got parts of that field that were 7.4 and parts of that field I think were 5.8 or 5.9. Obviously the 5.8 to 5.9 is money well spent, the 7.4 is money wasted. So it's about trimming back really where we can. What's TSP now? 500, 520, something like that really. It doesn't take a lot of TSP to suddenly save a bit of money and make your soil sampling certainly worthwhile. And obviously that's just 1 year. So I think it's about kind of using those inputs carefully and cleverly and trying to trim back where you can really, and obviously spend where it's worth investing on those low areas like that lime example.
Understood. Thank you, Harry. A question for you, Nigel. So how do we factor the SNS into the plan and understand the long-term yield potential to key factors in determining inorganic N requirement? Also addressing poor headlands in the field could bring up the field average.
That's a complicated question.
Do you need a moment?
I need a moment. No, it's a crucial question. It's important because I see it's that comes to going back to ourselves. Nitrogen use or the use of nitrogen has been probably highly inefficient, and taking all those factors into conjunction, with it SNS, the previous crop. Every season is different in terms of rainfall as well, in terms of soil temperature as well, and what's been mineralized. And again, I would say really it's that agronomist knowledge and understanding. Certainly, headlands when it comes to compaction now and it comes to biomass can be misleading, but I think it goes back to that agronomist knowledge and walking fields and an understanding there, because I say there's a lot going on there, and from that there you can factor in organic manure applications as well, and again use your knowledge what you're going to do, what you're going to apply, and again it's that field by field basis rather than treating it as it's a carte blanche approach. Just to
add to that, Heather, I think we've talked about probably putting more on worse, but actually the other way around as well. If there are, if there's no potential there or limited potential, it's about going, well, that headland actually is never going to do more than this. So trimming that back really. So it's both sides of the story really. It is. It's about the potential of the crop you've got, and the potential is not there. There's no point feeding something that's inherently got a potential of 7 or 8 tons. We're too easy to go and apply stuff over, the expectation is going to be 10 or 12 tons. That's not achievable everywhere.
Okay, thank you both. Interesting, you mentioned canopy, Nigel, and obviously the importance of that agronomist having boots in the field. We have a question here which says, this is our first year of using FieldSense. Last autumn, our variable rate seed drilling had to rely on previous 5 years of satellite imagery. It resulted in many areas of fields where lower seed rates were used, clashing with blackgrass areas in the fields. The blackgrass had shown up as being good or dense crop canopy. And our audience member asks, are you aware of this phenomenon? And how do we act against it?
It can pick it up, certainly. So obviously these seed maps are made from HPI imagery, which are an average of the growing season over the last 5 years, but you can pick the seasons you want. So you don't have to use those years. So if you've got a certain particular years you want to use, so say for instance the situation where you had a poor crop establishment, or it was in a spring crop for instance, you can pick and choose the years you want to use that you would say is your average in terms of its establishment. But yeah, Harry, do you got anything to add to that?
Yeah, no, I think along similar lines really, Nigel. I think in that situation I'd be going, obviously I'm guessing a lot of that was kind of wheat dominated kind of cropping, and whether you're using some different techniques for managing that black grass, and say you did have a spring crop in there or a broadleaf crop or something like that, maybe using that imagery actually and weighting that heavier So we're taking like multiple images every year and kind of overlaying all of those to get those kind of performance areas. But if you're weighting that with a lot of winter wheat that's got a load of black grass in, then obviously that's not going to give you what you desire. So I think if you just kind of pick and choose which years and which crops, then I think you could probably tweak that better to kind of address the black grass. You obviously also, as we've kind of demonstrated, can do that kind of manual rate. So if you have mapped that black grass, you can just go and, you know, say the performance shows us a lower kind of plant population required, but actually you can just override that with kind of your knowledge alongside, you know, whoever the agronomist is on the farm. I think that's, you know, that got that ability to kind of customize it to you.
Yeah, that's something I've adopted myself, and zoning fields off and ends up, you know, going, say for instance, you want your establishment, you're wanting 300 seeds a square meter. I've upped that to 350, 400, 500 on those specific areas. So again, with the gridding tool that Harry showed earlier on, you can do that.
Excellent. We have a question here from another FieldSense customer who just says they weren't aware about being able to access a dashboard. Is that a feature that's available to all customers, or do we have is FieldSense a tiered platform with some features locked off for certain users?
No. Anyone can use it. So if you purchase products on it, so whether it's full field sampling or whether it's VRA seed or combine and harvest data, anyone that has that can access it, and they get the same dashboard as I showed in the video. That sort of shut down dashboard with, you can view your results, you can download your reports, look at the weather, and any applications as well. So applications in terms of download the VRA files in shapefile form or in ISO Excel file as well. So you've got the ability to do that, and that's very handy at times where, say for instance, a grower's going to go and go drilling, and you can't get a hold of the agronomist. You can quite easily jump on the platform, download the actual files he needs, then he can be drilling straight away. So yeah, just to contact the local agronomist, and you can speak to myself or Harry and the other parts of the FieldSense team, and we can get the grower yourself uploaded onto the system, and not a problem at all. You'll get an email, welcome email. Just click onto it, and put your password in, and then you're working straight away.
Fantastic. Thank you for clarifying that one. Nigel just mentioned drilling. Harry, you talked about variable rate seeding. We've a question here regarding what is the effect of VR seeding on establishment rates? Can you give us a bit more info on those?
I think in terms of establishment rates, I guess, well, I think we always underestimate our establishment rates. We all think we have a perfect silt field where it's all going to kind of grow beautifully, even if we have tested at 95% germ. So I think we're kind of looking, going, oh, everything will do 80%. And I think actually if we go out there, like I say, doing those tiller counts, you see that we might range from 40% to 95% in some cases. Sometimes you get 105, which is quite amazing. But ground truthing those tillers and looking back to, like Nigel said, those seed rates of, you know, 100 kilos difference does show you that the range is bigger than you think, really. You know, I think we're all probably guilty of going, oh, that headland's a little bit marley or whatever, let's put an extra 10% on the drill, plus. And really, we're not really being brave enough. Nigel said brave earlier. It sounds unscientific to be brave, but I think actually it is, you know, we're all kind of at risk of not being bold enough, should we say, on that. So yeah, I think the establishment rates do vary a lot.
Yeah.
Excellent. Thank you. Nigel, quick one for you before we wrap up. What makes FieldSense different to other platforms? There are plenty of similar sounding platforms out there. Why is this one so good?
Well, Heather, I think the simple answer is partnership. You know, the agronomist working closely with the farmer or the grower. You know, I believe you get the best results, and that's key. And I think we talked about this ground truthing element of it. Having the agronomist working with the data with the grower on the farm is key to this. And I mentioned we've got examples of where it hasn't worked for other systems, but I think that's where we stand out, and working closely is the simple most important thing. So, and again, back to this precision and partnership.
Perfect. Harry, any words from you on that question?
No, it's just about people, isn't it, really? I think, you know, I think I probably started collecting yield maps out of combines like 25 years ago, something stupid like that. And they've sat on a shelf getting dusty. But I think it's about taking that data and turning it into something that's actually going to make you more money. And I think, yeah, where you can work together on that, that's what it's all about, really. So it's, yeah, the people, the partnership.
Fantastic. So I guess there's just one final question to ask then, Nigel. I'm interested. What do I do next?
Or go and speak to your local ProCam agronomist. That's important. Or try the website at www.procam.co.uk to find out more.
Perfect. Well, gentlemen, thank you so much. Very insightful, very detailed. To our audience, thank you so much for joining us this evening. I hope you found it useful. As Nigel said, the website is there for any further queries and questions that you might have, or speak to your local ProCam agronomist. But from the three of us this evening, thank you very much for joining, and good night.
Thank you.
Thank you very much.